So on your hyperdoc, as you're working through it, you have the first YouTube video, and then where it says read the information about winds found here. When you click on this link, it will bring you to this article, and that is what I'll be reading. Uneven heating causes air to move. On local news broadcasts, weather forecasters often spend several minutes discussing what the weather will be like over the next few days. Weather is the condition of Earth's atmosphere at a particular time and place. Wind is an important part of weather. You will read about other weather factors later in this chapter. Wind is air that moves horizontally or parallel to the ground. Remember that air pressure can differ from place to place at the same altitude. Uneven heating of Earth's surface causes such pressure differences, which set air in motion. Over a short distance, wind moves directly from higher pressure towards lower pressure. Remember that air pressure is the force that air molecules exert on an area. The illustration above shows a common pattern of air circulation caused by uneven heating of Earth's surface. Number 1 on the left side, sunlight strongly heats an area of ground. The ground heats the air, the warm air rises, and an area of low pressure forms. Number 2, which is on the right side of the picture. Sunlight heats an area of ground less strongly. The cooler, dense air sinks slowly, and an area of high pressure forms. 3. At the bottom of the picture, the white arrow. 3. Air moves as wind across the surface from higher towards lower pressure. Remember that gas molecules move faster when the temperature is higher. When the difference in pressure between two areas is small, the wind may move too slowly to be noticeable. A very large pressure difference can produce wind strong enough to uproot trees. The distance wind travels varies. Some winds die out quickly after blowing a few meters. In contrast, global winds travel thousands of kilometers in steady patterns. Global winds last for weeks. Uneven heating between the equator and the north and south poles cause global winds. Notice in the illustration at the left how sunlight strikes Earth's curved surface. Near the equator, concentrated sunlight heats the surface to a high temperature. Warm air rises, producing low pressure. In regions closer to the poles, the sunlight is more spread out because less of the sun's energy reaches these regions. The air above them is cooler and denser. The sinking dense air produces high pressure that sets global winds in motion. Earth's rotation affects wind direction. If Earth did not rotate, global winds would flow directly from the poles to the equator. However, Earth's rotation changes the directions of wind and other objects moving over Earth. The influence of Earth's rotation is called the Coriolis effect. Global winds curve as Earth turns beneath them. In the northern hemisphere, winds curve to the right in the direction of motion. Winds in the southern hemisphere curve to the left. The Coriolis effect is noticeable only for winds that travel long distances. Because the Coriolis effect causes global winds to curve, they cannot flow directly from the poles to the equator. Instead, global winds travel along three routes in the hemisphere. These routes, which circle the world, are called global wind belts. Global winds. Belts of global wind circle Earth. Because of the Coriolis effect, the winds in these belts curve to the east or the west. Between the global wind belts are calm areas of rising or falling air. A circulation cell is a giant loop of moving air that includes a wind belt and the calm regions that border it. Patterns of heating and cooling cause local winds and monsoons. Have you ever noticed how the wind can change in predictable ways? For example, at the beach on a hot day, you will often feel a cool breeze coming off the water. At night, a breeze will flow in the opposite direction. The change in the breeze occurs because water and land heat up and cool down at different rates. Local winds. Some winds change daily in a regular pattern. These local winds blow within small areas. Sea breezes and land breezes occur near shorelines. During the day, land heats up faster than water. The air over the land rises and expands. Denser ocean air moves into the area of low pressure, producing a sea breeze. As the illustration below shows, this pattern is reversed at night, when land cools faster than water. Warm air rises over the ocean and cooler air flows in, producing a land breeze. Warmer air rises over land during the day. Cooler air blows in from water. Cooler air blows out from land at night. Warmer air rises over water at night. Valley breezes and mountain breezes are caused by a similar process. Mountain slopes heat up and cool faster than the valleys below them. During the day, valley breezes flow up mountains. At night, mountain breezes flow down into valleys. Monsoons. Winds that change direction with the seasons are called monsoons. Like sea breezes and land breezes, monsoons are caused by the different heating and cooling rates of land and sea. However, monsoons flow longer distances and affect much larger areas. Winter monsoons occur in regions where the land becomes much cooler than the sea during winter. High pressure builds over the land, and cool, dry wind blows out towards the sea. During summer, this pattern reverses as the land becomes much warmer than the sea. Moist wind flows inland, often bringing heavy rains. The most extreme monsoons occur in South Asia and Southeast Asia. Farmers there depend on rain from the summer monsoons to grow crops.